problem 77, part 2, or is it B? 77B, and this is where we solve for the tension. So now, just think a little bit. We were able to ignore the tension if we treated the whole thing as a system, Robin Hood and the chandelier, okay? So now, if we're going to solve for the tension, then we're going to have to do what? Break the system apart, okay? And this is actually easy because we're well aware of what's going on in this situation. We've done these problems before. All right, to split up the system, we can either think about the chandelier or we can think about Robin Hood. To me, it seems a little bit easier to think about Robin Hood. Does anybody have any idea why it might be a little bit easier? Well, he's lighter, so we'd be using smaller numbers. He's going up. That's correct. He's going up, so our upward acceleration will be in the positive direction. It's more consistent with our sort of way of thinking of things, okay? So our typical frame of reference. So if we do this and we take upward to be positive, okay, then what force is acting up on Robin Hood? Tension. Good. And what force is acting down on Robin Hood? Weight. Okay, gravitational force is weight. Right? So now, when you see a problem like this, what does your mind immediately say? Well, they're not equal though, right? Because it's accelerating upward. So should I have drawn it a little bit more, more out of balance? If that will help, I will. So now we won't think that they're equal. What do you see when you see that kind of thing? All right, yes, who said it? Elevator equation, exactly right. Was that you, Ryan? Good. Yes, it is the elevator equation. We will get to the elevator equation. We know the net force in the y direction is equal to, this time it's not m plus m, it's just m for Robin Hood's mass, times the acceleration that we just determined. And we know that the net force is equal to, from the free body diagram, tension minus mg. Tension in the positive plus negative mg. All right? Setting those together, here's the elevator equation again. T minus mg is equal to ma. We're going to get there. You can sense it. It's happening. Wait for it. Wait for it. T equals mg plus ma, factoring out m. T is equal to m times the quantity g plus a. Ding. We're there. Okay? That's the elevator equation. So now all I got to do is plug everything in that we just determined. Tension is equal to mass. He's 77 kilograms times g, 9.8 meters per second squared, plus an upward acceleration of 4.25 meters per second squared. So we got kilogram meters per second squared. Kilogram meters per second squared is newtons. So we're talking about a force tension. We're in good shape. All right. So T, this is going to be equal to 14.05 times 77. So whatever that turns out to be. 1081 point what?
85.
How about 1082 or 1080 for sig fig sig, right? Look how fast that is. Okay, it was quick to do the acceleration by using that straightening out model. We know we did it algebraically. We could see that the answer, irrespective of any different masses it might be in, is always going to be big M minus little m over big M plus little m times g. Okay? And what do you know about that? It can never be greater than 1, can it? That expression in front of g, right? I know I'm going backwards a little bit, but if we take this right here, big M minus little m over big M plus little m, that can never be greater than 1, can it? You see why? It can never be greater than 1? And something that has to do with gravity accelerating can never be greater than gravitational acceleration, unless there's rotation involved, but that's not something we'll talk about this year. Okay. Are these questions that'll be useful to have on the video? How about yours, Edward? Okay, ask it. Any way to do this without the Texas two-step? Well, for right here, what we would have to do is put in the expression big M minus little m over big plus big M times g. So, yeah, what we could do would be this. We'd say T is equal to 77 kilograms. Well, let me do it algebraically. First, let me drop the eraser. Actually, let me do it as a different video, and then we'll come back.